Welcome to Học Tiếng Anh với Joseph, where we build vocabulary and practice pronunciation through reading. Continuing with The Cat in the Box, A History of Science in 100 Experiments, today we will read story number 85. Hôm nay chúng ta sẽ đọc truyện số 85, Masers and Lasers. Masers and lasers are among the most ubiquitous inventions in modern society. They are used in telecommunications, supermarket barcode readers, Blu-ray and CD players, fiber optic communications, and in many other applications. The idea behind them goes back to an insight from Albert Einstein in 1917, but the key experiments proving that the idea could be turned into practice were carried out by Charles Townes and his colleagues at Columbia University in 1953. Einstein's insight is another example of the curious wave-particle duality of light and other electromagnetic radiation. He realized that if an atom had an electron in a so-called excited state with extra energy, then a photon with a certain wavelength passing by could make the electron fall down into a lower energy state, releasing another photon with the same wavelength as the first one. There would be two photons instead of one. This became known as stimulated emission of radiation, but for a long time it was regarded as a quantum mechanical curiosity with no practical value. In 1951, however, Townes realized that with the improvements in technology developed for radar work in the Second World War, it ought to be possible to apply Einstein's idea to create intense beams of radiation at microwave, shortwave radio wavelengths. If a whole array of atoms could be prepared in the excited state, then in the process like that of a runaway nuclear chain reaction, one photon could trigger emission from one atom, providing two photons to trigger two more atoms, then 4, 8, 16, and so on. Crucially, all these photons would have exactly the same wavelength. Marching in step and never cancelling one another out. This is known as coherent radiation. Townes called the process microwave amplification by stimulated emission of radiation, which got shortened to the acronym MASER, and then became a new word, maser or laser or maser. The same theoretical idea was also developed by Nikolai Basov and Alexander Prokhorov at the Lebedev Institute of Physics at about the same time. But neither team knew about the other group's work until after Townes, working with James Gordon and H.J. Zeiger, had constructed the first working maser. In the key experiment, ammonia gas was radiated using microwaves with a frequency of just under 24,000 million cycles per second, or 24 gigahertz. This put some of the molecules into the required excited state. The gas then passed through a device that used electric fields to extract most of the remaining unexcited molecules, which have slightly different electrical properties to the excited molecules. What was left was a gas in which most of the molecules were in excited state. This is known as a population inversion because it is the opposite of the usual state of affairs. And the whole process of creating a population inversion is known as pumping the molecules. It was then possible to trigger the maser process, which produced a coherent amplified beam of pure radiation at the same frequency, 24 GHz, as the incoherent radiation originally used to excite the molecules. This is equivalent to a wavelength of just over 1 centimeter. The amplification took place in a cavity with a carefully chosen dimensions, in effect a little metal box, so that photons could not escape but were bounced back to trigger more emission. Excited molecules passed through the cavity in a continuous stream to keep the process going. The experiment of 1953 paved the way for the construction of the first fully functioning ammonia master maser in 1954. Its power output was just 10 nanowatts, 10 billionth of a watt, but it proved that the trick worked. With the principle established, other researchers were quick to develop a variety of masers and to scale up the energies involved. Although they knew that the same physical processes ought to work for light as well, it was much harder to work with light because it has much shorter wavelengths than microwave radiation used in the ammonia experiment. But by 1960, the first system using light had been constructed. It was originally called an optical maser, but such devices quickly became known as lasers, with the word light replacing the word microwave from maser. In 1964, Townes, Basov, and Prokhorov shared the Nobel Prize in Physics for fundamental work in the field of quantum electronics, which had led to the construction of oscillators and amplifiers based on the maser-laser principle. A year later, in 1965, a strong source of microwave radiation from space was identified as the result of a naturally occurring maser involving the molecular radical OH in an interstellar gas cloud. Since then, at least a dozen other astronomical maser molecules have been identified, including water, ammonia, hydrogen cyanide, and methanol. It is not yet clear how these molecules are being pumped into their excited states. Now to the vocabulary section. Ubiquitous, telecommunication, insight, intense, coherent radiation, acronym, population inversion, cavity, nanowatt, laser, oscillator, amplifier. Thank you so much for your attention. As usual, I will see you in the next story. Bye for now.